All right, so we know what degrees are. Let's get into radians. This is another unit of measurement for angles. And it turns out it's actually nicer mathematically than degrees. Why that's true, I'm not sure if the book goes into it, but why it's true anyway, I really don't have time to go through. And actually what I have here, as I wrote here, I did not write down a formal definition of what a radian is. It turns out it's not terribly involved. I figured for the class, though, for Math 104, that is, it's better to just skip it. You know, we only have so much time as it is. What does turn out to be true, though, is 180 degrees turns out to be pi radians. I guess if you want, you could think of 1 radian as the same as this, if you want. It's 180 divided by pi degrees. And then you could get 1 degree in terms of radians, like so. And from here, we can come up with a method for converting between degrees and radians, or the other way around. Namely, to go from degrees into radians, you multiply by this, pi over 180 degrees. And if you want to go from radians to degrees, you multiply by this. I mean, normally with my students, you know, if they have a test that's closed book, I tell them a way of remembering this is from radians to degrees, you want your answer to have degrees in it. That means you really want it in the numerator. In the denominator, odds are it's going to cancel. I mean, you could also just go from here and then divide. I mean, you could do that, but you know, this is what we do. I mean, here the tests again are open book, so I guess that's really not too much of an issue. I did email you guys the notes. You know, it should be in your inbox, your email inbox, that is. Okay. Also, I have it written on the next slide, but let me say it here. You don't convert pi into decimal form. Okay? We don't do that. I know it's tempting to write pi as 3.14 or whatever, but leave it as pi. And also, people don't generally write down radians if the angle is in radians. For instance, with degrees, we have notation for specifying degrees. This is 180 degrees. Well, people don't really write down radian. Usually it will be clear from the context that this is an angle. And if you don't see the word degrees or a symbol like this little circle that the laser is almost covering, then it's understood to be in radians. So, okay. Now, again, don't convert pi into decimal form. So these are just some examples I did. 90 degrees, you can convert that into radians. As I'm doing here, we're multiplying by pi over 180 degrees. The degrees actually cancels. You're left with 90 times pi over 180. You really want to reduce that if you can, but hopefully it's easy to see that 180 is 90 times 2. So you end up with this. So our answer, I didn't write out the word radians, but it's understood this is in radians. And the answer has pi in it. That's okay. That's very common. When you're dealing with an angle in radians, you don't have to necessarily, but it is common to have the angle of pi in it, the pi in there. 270 degrees, right? Same idea. We're going to convert this to radians. We multiply by pi over 180. We get 270 pi over 180. And it turns out 270 is 90 times 3. Let me actually, you know what, I didn't write it, but let me write it here. I feel bad if I don't write it. Back here with the 91. Actually, no, wait. that. I should have showed more work. I'm sorry I did not. Let me just do that now. 180 is times 2. So hopefully from here, since 180 is 90 times 2, you can see that the 90s cancel. Here, what we have is 90 times 3 times pi. Okay. All over 90 times 2. Now you can see, hopefully here, that the 90s are going to cancel, and you're left with 3 pi over 2. Here, we had, well, yeah, I said that already. To go from radians to degrees, okay, to go from radians to degrees, we're going to multiply by 180 degrees over pi. So we want our answer to have degrees. So the degree symbol we leave here, we end up with this. And notice we can cancel the pi. Really good to do that. And so we're left with, you know, when the dust settles, you get 2 times 180 degrees over 3. That's the same thing as 120 degrees. Pi over 3 radians, same idea. We multiply by 180 degrees over pi, okay? So we get this. Pi's we cancel. And 180 degrees over 6, that's 30 degrees. You know, the degree symbol you leave in there, your answer is going to be in degrees. Okay. So that's what we have here. Just fix something. I know I'm thinking about this too much, but I really just want to make sure everyone understands. Let me do this. Have in D. Oh my goodness, pi all over 180. I'm just trying to rewrite up here. I'm just showing you that 180 is actually 90 times 2. Just quickly fix that. There we go. 90 times 2. So now the 90s cancel. So we get pi over 2. All right. So this is what we get here. Now I figured it'd be good for everyone to try these on their own. You know, in the next slide, I have some examples. Are there any questions about this?
Isn't there a mistake on the last problem?
Here?
Yeah, because you go from pi over 3 to pi over 6.
All right, Vayasmir. Thank you. I was testing to see if you guys were paying attention. Nah, that joke never works, I know. Thank you. Darn. See, I make mistakes. Okay, so any other questions? Okay. All right, so now for this one, I want although pi over 3, I guess that's kind of, oh no, I didn't do that. But, okay. So these, I figured you guys should try on your own now. You know, it'll take about 5 minutes. So I'm going to stop the recording. Keep that. And let me just, although wait, the notes might, well, try it out on your own. Oh wait, I think the notes.